I am very excited to get to introduce a good friend of mine to you all today. So I first met Sunny several years ago as part of the Tennessee Geographic Information Council. At the time of, so let me back up, that's our state geospatial group. So it's a volunteer-run nonprofit that's all about promoting geospatial technology across the state. So that could be everything from educating people about how to use it at the local or state government level, all the way up to advocating for funding to get certain types of data collected. So it covers all the different aspects of it. And at the time, Sunny was working for the Tennessee Department of Environment and Conservation. So she was working with the Tennessee State Parks Group, doing all the GIS work for Tennessee State Parks. And she went to an ESRI conference, the company that makes all the GIS software that we've been using. And she opened her mouth about how whatever she was using at the time was really frustrating. And ESRI said, you've got strong opinions about this, about ways to make it better. Maybe you'd like to come work for us and help us. So ESRI got scooped up, or somebody got scooped up by ESRI and has been working there. How long is this now, Sunny?
Year 3, I think. So three-ish years.
Yeah. And then as part of that, just to kind of give you another cool thing that Sunny's been working on, a big part of what she does is supporting local and state government and helping them identify ways to utilize geospatial technology to solve the problems that they're facing. And a big component of that then recently has been the new infrastructure bill. And Sunny is probably the only human being on the planet who has actually read the infrastructure bill cover to cover. Wow. She's annotated the whole thing, and she's spent a lot of time showing people in local and state government how they can use what's in the infrastructure bill to help solve their problems, but also with a strong climate focus with what she's working with.
Will you hold that up again? I'm sorry. I want to take a snap for that.
This is my annotated version of the infrastructure bill. So yeah, I had it printed at Kinko's, $150 FYI if you want to do that. Yeah, good times.
It's amazing.
Let's see. And then the last really cool thing I want to share about Sunny before we turn it over to her is that Sunny is currently the vice president of TNJ, which means that in a few months, in April, when we have a big meeting, she will take over and be the president of the organization. And that's a 1-year commitment to be president. So you spend 1 year as vice president, 1 year as president, and then you also commit to staying on in an advisory capacity as a past president on the board. So Sunny is definitely someone who puts her heart into what she does. Okay, Sunny, you ready for your question?
Yeah, what is it?
Your question is, would you rather explore space or the deep sea?
Wow, okay. I would rather explore the deep sea. Little known fact, and I wasn't planning on even talking about this today. Great. I almost went into marine biology, and then I became an art student. That was like my 2 things. And then I went back to biology, but through botany. So and then I started scuba diving just a couple of years ago. So I've come full circle, but yeah, marine for sure.
All right, well, Sunny, I think we're ready to turn it over to you, and let you take it over.
Awesome. All right, I'm going to go ahead and get my screen shared here, and that should be popping up for folks in just a minute. Let me know if it's not.
Perfect.
All right, excellent. And let me get my little doohickeys. All right, got all my ducks in a row. You got to like navigate your own desktop, right, before you get started. All right. So in the words of David Byrne, how did I get here? I've had a really interesting career, and I know a lot of us in the room today are educators, and I have an interesting relationship with academia, both a good one and a bad one. And so I was thinking last night, oh, how much should I go into details on certain things? I don't know. So we'll see where I go today. This will be a really casual conversation. I threw together kind of pictures throughout my life, maps I've made throughout my life, mostly terrible ones. But yeah, I work here at ESRI now, and I am actually, as of think 2 months ago, beginning of this year, I have transitioned into a role here at ESRI where I am our industry lead for environment, conservation, and natural resources. Environment I own fully at ESRI. Natural resources I help support because there's a lot of crossover there, obviously, and conservation I also help support because there's a lot of crossover there. But environment is kind of my baby now here at ESRI. And what does that really mean? It means that we do outreach. Our user community is extremely important to ESRI. And, Michael kind of mentioned this already. My role when I started here at ESRI was to support our state environmental agencies. So I was working with all 50 state environmental agencies times however many environmental agencies they may have. That included forestry, agriculture, state parks groups, fish and wildlife, and then kind of the environmental regulation side of things, which is, as I've gotten older, there's different topics I find myself attracted to throughout the years. And right now I'm really kind of fascinated by environmental policy, and hence why I would suffer through reading something like the infrastructure bill, which I could talk about, I don't know, maybe later today. Maybe we'll get into the infrastructure bill if you want, we can talk about it. But yeah, so that's where I'm at now. And it's been a kind of a really interesting journey. And Michael mentioned it. I'm kind of opinionated and I open my mouth quite a bit, and I encourage others to do so as well, in a nice way, in a gracious way. Kindness is king. And yeah, so ESRI thought, well, why don't you come work for us? So that's how I kind of ended up here. But I want to talk a little bit about ESRI and about how we kind of think about the world and the values that this company holds. So we were founded by Jack and Laura Dangermond. They still own the company. It is a privately owned company. They still own it. They still literally run the company. When I got hired into this new role, Laura was the one that signed off on it. So they're very much actively engaged with how our company is run and what our core values are. And every year we have a conference, the ESRI UC, it's out in San Diego. I encourage folks to go there. It's more than just a bunch of tech geeks getting together. It's really about solution oriented. This technology is a tool, yes, but there's so many topics that we're kind of tackling across the world. And our theme for 2021 was creating a sustainable future. And every year, our ESRI UC theme somehow reflects these core values that both Jack and Laura hold and expect of our company. And so creating a sustainable future was our one from last year. And the reason being is that we feel that a lack of understanding of our reality, and our reality for us is geographic. It exists somewhere on Earth. Everything happens somewhere on Earth or even in space. Our lack of understanding these relationships is one of the greatest risks that our society is facing today. And that our future really depends on having a better understanding and applying that understanding to be solution oriented. And we do this through something called the Geographic Approach. This is how we think about the world. This is how we approach everything from environmental issues, but also to business. We work with all sorts of different sectors. So we started out, ESRI, FYI, is an acronym actually for the Environmental Systems Research Institute. And our footprint now has expanded though to, we work with Apple, we work with the Facebooks, there are business partners in this space for better or worse. We work with Walmart, we work with Walgreens, we work with other tech companies. We support environmental agencies, yes, but we also support transportation agencies, health and human services. So we're really kind of inside a lot of different sectors, and it's because you can apply the geographic approach to any of them. That is, do you need to analyze something? Do you need to visualize something? Do you need to design something or collaborate with people? And how do we kind of account and measure these things and put metrics around them? And so we organize that into a framework. You start with this measuring, this assessment. That allows you to kind of predict how things happen. This helps our understanding. We can then apply that and make decisions around that and take real action on that. And I think you all are acutely aware of this because you're already doing this through Megabytes. And the way that you all are asking your students to think critically about this data and apply that, there's a heavy geographic component. You all are already using our tools to kind of apply this understanding and move down this path. So this is really a framework. This is a framework for how we think, critically. So this is very core to ESRI. And there's some corporate stuff in here. We kind of build it around the system of insight. This is the analytics, the system of engagement, visualizing this for people through apps and maps, and then the system of record, kind of that transactional stuff, data where it really lives. And it can be applied to really any device that we have. So whether you have like a server that's sitting in your house, I used to have LAN parties when I was a kid. So, I had these giant machines where I would play games. That is kind of my server at the time. Whether you're just on your desktop or laptop, or whether you're using your mobile device, or whether you're needing to kind of interface with other applications that people build or in the cloud. So this is kind of ubiquitous. No matter what device you're using, the geographic approach and ESRI's platform can be applied to it. So I wanted to run through some just quick examples of how this is used across the globe, and specifically kind of to the environmental lens. So environmental monitoring and assessment is big, and I think you all are doing some monitoring, of course, with mosquitoes, but we have examples on the screen here from all over the world. So I won't go over these one by one. It's just kind of to give you an idea of the vast array of application of this technology. Natural resources management, so things like prescribed fire, disease and pest monitoring, inventory, planting, anything that we're kind of doing on the ground to either use, take care of, or otherwise kind of steward our landscape that can be applied here. You see a lot of 2D here, but we're also getting into 3D here because there's, of course, a topographic component to geography, and that's really important. So being able to visualize that. Conservation assessment, planning and management. Right now, we have something called America the Beautiful Act, and this is part of an initiative called 30 by 30, and this is a global initiative. And the idea is that in order for us to have a sustainable future, we need to protect at least 30% of our land and water by 2030. And so that requires a lot of planning. It requires prioritization. We're not going to be able to conserve everything everywhere, and certain things may be more worth conserving than other things. And there's trade-offs with economics and things like that. A lot of complexities that come together when we do conservation planning. And so using a geographic approach can allow us to overlay these complexities of information to do this kind of planning. And it's actively being done. It's not a theoretical thing. These are a lot of examples of that. Energy and utilities. I put this on here. It sounds like, oh, is that environment? Well, it very much is. And I think we know this acutely. Whether it's oil and gas, whether it's natural gas, whether it's solar, whether it's the movement of the ocean to capture that kinetic energy and drive energy into that. A lot of different ways that we derive energy, and it all starts with some of our natural resources. And so the relationship between our natural resources, the stewardship of our environment, and our energy consumption is really important, and protecting that infrastructure from natural disasters as well is also important. So there's a lot of different examples of how we can use it for our energy utility space. Disaster preparation and response, I just alluded to it, kind of protecting ourselves, protecting our infrastructure from natural disasters. We know that we're having increasing flooding. We see this a lot, of course, in Tennessee. Out west, we have a lot of increasing fires. We have drought, so water access, water issues. These are all things that we're looking at, and how disasters really exacerbate these issues, and how we respond to them, and how we plan around them. Social equity is very important here as well. And I even have an example of this a little bit later. People are like, oh, that's not environmentally related. Well, it absolutely is. And it's something called environmental justice. And it's how we treat our environment, and who gets the brunt of some of the worst effects and who doesn't. And can we afford that? Can these populations afford to face that? Or do we need to be more equitably distributable in, first of all, what those impacts are, but also how we mitigate these things? Where can people go on a walk? Where are our parks? Where are green spaces? What are these like? There's a lot of complexities here, and you'll see this. There's food insecurity. There's the relationship of redlining on how we see things conducted today, trails and equity planning, poverty and access to legal resources. I know, Michael, you had a student, Annie Liu, who did a great story map about legal resources and access to them. Fantastic. Mapping racism, all these really complex topics. And geography helps us wrap our heads around them in a way that's objective and that we can actually move forward in the conversation and not just feel angry at each other. We can understand these things. Really powerful. Okay, so that's all the good ESRI stuff. That's how our tools are applied, and I could go on all day about how the tools are applied, but I wanted to put those examples out there, just kind of get you all thinking about that. But what about my own journey to GIS? It's one thing to have a corporate slide deck and see all the pretty pictures, but it's another thing to think about yourself individually and how you relate to how you may think geographically or would like to think geographically. And so I think the rest of this presentation is very personal in that way of what was my GIS journey. So I'm going to start with this picture. This is me in the clashing colors on the right with two of the kids that I grew up with in my neighborhood. Tad Peterson over here on the left was my absolute best friend growing up, and Doug was my neighbor next door. My father, you can barely see him in the background. We had just purchased this house in Franklin, Tennessee. And I quickly became very close friends with these two, and we would run around our neighborhood, and we both, all of us read fantasy books, and we would draw maps of our neighborhood and rename our houses or these places that we felt were really important landmarks in our neighborhood and rename them to these places that were in the books. And we would pretend to be the characters and we would run around. And I so desperately wish that I had some of those old drawings that I had of when I would draw maps of my neighborhood and all the houses and where all the kids lived and who we were and what they were called. But that experience growing up, I was already thinking geographically at that time. Yes, it was through the lens of fantasy and play, but it was, I think, a really important development in my childhood. I was outdoors, we were running around, and I was thinking about those spaces and how they interact and play together and who lived next to who and what characters we pretended to play. So those complex relationships were already playing out for me, kind of in a mapping sense. So later on, a little bit more grown up here, I was in college at UT Chattanooga, and I was an undergraduate. So here on the screen, this is Dr. Dwayne Estes. He's at Austin Peay State University. He's not that tall. He was standing on a rock. This is Dr. Joey Shaw. He's at UT Chattanooga. Theo Witzel. He's the Arkansas heritage biologist. And then these are a few of the grad students at the time. A couple were in Chattanooga, and well, he wasn't a grad student. He's a professor. And I think he was at Austin Peay. And we were out botanizing. This picture was taken in Georgia at a place called Stone Mountain. And there's, pictures all throughout my career here from things I was fascinated by or plants that I got to see. But my time at UT Chattanooga was really interesting. I was hired. Dr. Estes and Dr. Shaw had a grant. It was about $250,000 grant that they got to study the Ocoee River Gorge when the landslides happened. And they hired me on this project as the undergrad, basically to press plants and grab coffee. And I learned that GIS was supposed to be our deliverable back to TVA, the US Forest Service, and a couple of the other entities that were paying us for the study. And Dr. Estes, who's one of both these guys, they're some of my best friends, so I can say this now. Dr. Estes knows nothing about GIS. He never used the software. And I'd happened to have an internship at the Air Force Base, at Arnold Air Force Base, where I had, I think, opened the software once. And so I told Joey this, Dr. Shaw here. I told him, I was like, Dwayne's not going to deliver GIS, let's have a plan B at least. Let me kind of take on plan B using GIS and doing this stuff. And so he said, okay. And what that experience turned into for me at UT Chattanooga, I'd been a full-time student, and this is where my relationship with academia gets kind of tricky. I was a terrible student. I had zero interest in classes. I was so annoyed by them. I didn't like being told what to do. I didn't like homework. I'm sure you all have experienced this in your students where you have someone who's probably as subordinate as I was. So I scaled back my classes to part-time, and I threw myself into this project in the Ocoee River Gorge. And for the next 4 years as a part-time student, I pretty much lived in that botany lab, teaching myself GIS. It was ArcMap 9.3 at the time, so some of our older software. And I don't know, I just fell in love with it. And I think I know why. Now that I'm older, I kind of understand why I fell in love with it. But here are some of the first maps I ever made. They're absolutely terrible and jarring. These are from the Ocoee River Gorge. So these two on the right, I was looking at, I think, some slope analysis. So this is really old school raster analysis that I was playing with. I really fell in love with rasters versus something called vector. And if folks have questions on that, we can get into it. I fell in love with kind of making base maps. This is a custom base map I made at the time, pretty crude now that I look at it, but at the time it was like, whoa. And then of course, this is all the work we conducted. We were out in the field conducting this work. I had a handheld GPS, and then I did some very crude modeling at the time to kind of pull out these different ecological systems and then use our data to really ground truth the stuff. So I taught all of this to myself, and later we were able to apply it on a couple other small grants that Dr. Shaw and Dr. Estes got. So that was kind of the beginning for me of GIS and really diving into, yes, botany, but it really wasn't the plants or the nomenclature, kind of those botanical applications that I really loved. I found that it was the software that I loved, being able to ask questions, being able to see things at any scale I wanted to, and kind of answer questions for myself, really empower myself. That was really powerful for me. So closer to the end of my career in college, my friend Kristen here she is eating peanut butter or a cracker or something in our tent. We lived together in a tent for about a month in Madagascar. And she was at the University of Massachusetts, and she was the TA on a trip to take a handful of students from the University of Massachusetts at Amherst to Madagascar, where she was doing a bunch of research on lemurs. And specifically, her interest is in disease vectors and zoonotic diseases. So things like, we know these now, coronaviruses that, could escape from bats or populations and things like that. So she was actually looking at disease vectors in lemur populations and how they were impacted by forest degradation. And she said, hey, Sunny, we'd really love for a botanist to come along and maybe do some research on what are the lemurs eating and how does what they're eating change when they're in fragmented forests and their habitat's not intact anymore. So her and I and a bunch of other students, this is Nina, he lives in Madagascar, he's from there. We would run around catching lemur poop, and I was measuring ferns, and then we would look at their poop under microscopes and categorize these different parasites and things that we'd find there. I was doing a lot of botanical collecting then, and because we're in the rainforest here in Tennessee, when we collect plants, we dry them. When you're in the rainforest, nothing ever dries, it's constantly raining. And so we had to actually preserve them. I would press them and then preserve them in alcohol. So it was kind of an interesting application that I learned there. So these are some of my plants that we pressed, and I made some maps while I was there. This wasn't my most prolific map making time, but here I made this map in the back of a taxi cab in in the capital of Madagascar. And I was trying to kind of communicate where we needed to go and where we were. So this is one map I made. And then this is another map I made, again, really crude. And this took me into a space where I started finding data in other countries. I think we really take for granted here in the US how much data we have available to us, which is crazy because there's so much more that we should have available to us. And trying to find data for one of the poorest third world countries in the world was really tricky, but I managed to find, I think, some DEMs and create some slope stuff out of this. And I had just taken some really crude points on places that I was in Madagascar. So I was mostly in central eastern Madagascar and northeast Madagascar while I was there. So just another application, another thing that really, at this point, everything I was doing, I decided I was putting it into a map somehow. Crude maps, yes, but I was mapping everything. So that experience with the Ocoee River Gorge and in Madagascar, I started to gain a reputation for myself. So classes and grades aside, which were very poor, my reputation and my networking within the botanical community here in Tennessee landed me a job with the Tennessee Division of Natural Heritage straight out of undergrad. And I was like, thank God, because I did not want to go to more school. I was just not a good student. So they hired me straight out of undergrad to be a recovery biologist with their heritage program. So I was going around to some extremely rare habitats in Tennessee. All of these are from the Central Basin. We call them cedar glades or limestone glades here in Tennessee. And I was monitoring our federally threatened and endangered plant species. So this was extremely rewarding work, as you can imagine. And I was thrown into kind of a botanical culture at that time that they weren't really using technology very much. And for me, that was, I wouldn't say frustrating, because I love my pen and paper. I love being out taking notes in the field. But when it came time to come back and do the reporting, I didn't like being in the office. I didn't want to spend a lot of time writing reports and doing these things. I wanted things to be efficient. I wanted this data to come in. And so this experience started pushing me away from what I call desktop GIS, making static maps, and using more field mobility tools, taking digital applications out into the field and capturing that data while I was out there so that I didn't have to spend time dealing with it or analyzing it, because as soon as I got back to the office, it was already up there. It was in the cloud. I was able to analyze it immediately or set these things up. It was really powerful. So while I was doing that botanical work, I became obsessed with this little salamander. This is Ambistoma barberi, the Streamside salamander. And I say discovered it, I would say rediscovered it in the Central Basin of Tennessee. And nobody thought that this thing existed in Tennessee. And turns out it's actually quite prolific in Middle Tennessee. And nobody ever knew. They weren't really looking. But at the time, we thought it was really rare. And so this took me down a path. Prior to this with GIS, I was just kind of making maps, static maps, laying things on top of other things. I wasn't really doing a lot of modeling or analysis. This species pushed me to conduct analysis. And that analysis, here's some pretty maps, yay, good stuff, rasters, things like that. Had to make sure you all got pretty pictures. But here in the Central Basin, this bottom central image here, this is the first real predictive analysis I ever conducted. And I conducted this using, this wasn't ESRI software at the time. It's a software called MaxEnt, or Maximum Entropy. It's an open source software that I started experimenting with, where we knew where some of our presence points were. So we knew where the salamander existed. And I wanted to ask the computer, based on different abiotic or even biotic variables, where else might the species exist? And this is the return that we got. And we were kind of surprised, because it's really the places that are in red and yellow here, really kind of hard to see. That's where it was saying they would be most prolific. As time has gone on and we have field biologists that are using this, we have environmental consultants, like my husband takes advantage of this map quite a bit. We are now finding them quite a few places. And so it kind of makes sense. And if we were to rerun this analysis today, I think the prediction would be much different. I started doing this also with fireflies. And this was when I worked for Tennessee State Parks. We discovered in the Great Smoky Mountains, and you all may know this, there's a rare firefly. And people come from all over the world to see this in the spring. And we discovered that we had this firefly at one of our parks. And so our commissioner at the time, wanted to advertise this, because Tennessee is one of the only park systems that doesn't have an admission fee. And so we have to find other ways to monetize and generate revenue so that our parks can stay open. So he was all excited about this, because he knew how much, the Smokies was making off of this event. And so he wanted to do that as well. And so I thought, well, let's do one better. Let's figure out where else in Tennessee this could be. And I can use predictive modeling for that. So I worked with one of the premier biologists that collects this data, and she sent me all of her data point that she has for North America. I clipped it to Tennessee and I ran the model based on those variables. And it was kind of interesting, because we have some spots popping up over here, but we have parks all through this area. So this really allowed us now to look at ecology kind of through an economic lens in a way. How do we start applying these two things? I know people feel sometimes like that can be, you know, economics, capitalism, all this stuff. These things can coexist. At the time, this is kind of a really crude application of that. We were thinking of a very one-to-one thing, but now that I work at ESRI and I'm working in these kind of more complex scenarios, there's a real relationship between how we steward our natural world and how we survive and have livelihoods. And I think that was kind of a really powerful lesson. So I want you all to kind of take a look at this, because I've talked a little bit about the complexities between things, and I want the crowd to kind of speak up here and tell me, first of all, what do you think these maps are? And do you see a pattern? And can you describe that pattern to me? So I'll open that question up to the audience. Silence is king.
Well, I think I have an idea on the one on the left.
Okay, what's the idea?
Based off of the shades of red and blue and the fact that Davidson County and Shelby County are both blue, I'm leaning towards presidential election results at the county level.
Yes, these are the 2008 presidential election results, I believe. I want to say it's 2008. This pattern, though, follows very similarly in 2016 and in other elections. Now, do you all notice kind of this crescent pattern here?
Yeah.
Look here. So it's kind of hard to see on the line, but we've got Georgia, you know, Alabama, Mississippi, South Carolina here, and there's that same crescent. And what this map is actually of geology, underlying geology. What are your thoughts on why would these both follow that kind of crescent pattern? Any ideas? Guesses?
Maybe major cities.
Oh, major cities is a guess.
Major cities that's a good guess. It's not, there's a relationship there too, but
Soil fertility.
Ooh, soil fertility.
soil fertility is getting real close. Yes. Paula says water. Okay. These are good guesses. So I want to emphasize that I'm a human being. We all are human beings. Yes, I love botany. Yes, I love ecology. Yes, I love GIS, but I also have thoughts about, you know, morality and politics and values and my spirituality. And I think when we're working with our students, we have to recognize they're all unique, right? And there's a way that we can apply GIS to start examining these kinds of relationships. And I think this is a really powerful example. So someone mentioned soil fertility. This is a map of cotton production in 1859. And you can see that this crescent here is there. And what are the ugly side of these economics that we're still dealing with today?
Oh yeah, all the racism and everything that goes with it.
Yeah. And this is a map of the percent slaves in 1860. And you can see this crescent here as well. So this crescent, the fertile soil from the Mississippi embayment, the coastal plain, and how it receded here, developed something that's called the Black Belt Prairie. This Black Belt Prairie was really fertile soil. And so it was great for cotton production. And the way that these economies sustained cotton production were by slave labor. And these populations today, 2008, 2016, 2020, it doesn't matter. You can look at any election map and you'll see this crescent, still impacts how behavior is influenced by geography today. These are really complex relationships. Any thoughts on this? Has anyone ever seen these maps before?
This is all new.
Seen the
Okay.
one on the bottom. Right?
Yeah.
Yeah. Isn't that a line?
There was a great, and I can send the link in the chat. There's a great New York Times article that really examined this relationship. It's really fascinating, but when you're thinking about geography and lesson plans and things like that, the thing I love about GIS is that, and you all were already kind of going down this path, even with the mosquito thing, there's this data that we have, but the data just leads to other questions. And geography allows us to, maybe I don't care about mosquitoes, but maybe I'm fascinated by climate. And these kinds of questions allow us to start examining all sorts of different relationships. And using geography and GIS allows us to examine these really complex relationships, even if they're all kind of tied to a similar theme. So I think it's a really powerful software. I love seeing it used in the classroom because I think it allows students to, maybe students that are like me that didn't want to listen and wanted to go off and do our own topics and explore our own things when we were ready to explore them. I think it allows for a lot of that creative freedom. And it really is a science. It's the science of where. Geography is the science of where, and that is ESRI's slogan. So I wanted to put that out there. I think we know this acutely now. This is going beyond static maps at this point, and over the past couple of years, this is a map that I would put my life on, everyone having seen at least once. Reason being is because this was hosted on ESRI's cloud. This is the Johns Hopkins COVID-19 dashboard. And as far as I am aware, it is the first time ever in our human history that we have mapped in near real time the spread of a virus. And Inxing Dong, who made this map, I don't think he understands his place in history. He's so humble. But he has really kind of revolutionized epidemiology in a way by using real-time mapping to do this. And one of the statistics at the peak of COVID and when this map was being looked at, so there's 7.75 billion people in this world. And I forget the statistic exactly, but it has been seen enough times that theoretically, every person in this world would have seen this map twice. That's mind-blowing to me. And because it was sitting in the cloud, because it was sitting on ESRI's infrastructure in the cloud, they were able to scale that. Usually that would come crashing down. We used to have and still have things called DDoS attacks, where you log into something so many times so quickly that it just crashes your server. Well, in the cloud, that's a lot harder to do because these things can scale. And that's allowed us to start doing things globally like this, where we're mapping disease in real time. Just absolutely mind-blowing. So it goes beyond just static maps, is really the point there. And I think you all kind of know this. We use something called ArcGIS Hub for the Tingic Map Gallery. I'm gathering statistics in real time when our judges come in and do their scoring. I'm not having to tally this, the computer's doing it. I've set up a neighborhood initiative. So this is kind of speaking to scale for Tennessee Fireflies. As you can tell, I'm kind of obsessed with fireflies, and it's my low-key way of fighting light pollution in the neighborhood. And so I've gotten the neighborhood to commit. So these are all the pledges from my neighborhood folks on the map for different ways to mitigate light pollution and promote firefly habitat in their own backyards. So it kind of speaks to scale there. And it's going beyond just kind of these niche little ways to use them. This actually just came out 2 days ago. This is the Kentucky Energy and Environment Cabinet. They've stood up a hub. They have to, every state has to report to the EPA on different metrics related to all of these different initiatives. And so this one is specific to the Clean Water Act. They have to report on their waters of the state and the quality of water. Usually and historically, they'll maybe send in a spreadsheet or a laboriously typed written report. Kentucky, and this is the first time as far as I'm aware, they asked the EPA if they would approve the use of an ArcGIS hub for this reporting, and the EPA approved. So this ArcGIS hub, which has dashboards, all of this, just like your Megabytes hub, is now being used to report up to Congress on Kentucky's water. So really powerful software. It goes beyond just maps. It just applies that geographic thinking. So just encourage you all to kind of think of all of the creative ways in which this technology can be applied, the breadth of which it's applied, and the ways in which we're finding geography kind of make its way into our society and how we think about things. So that's what I've got for you all. I don't know how much time we have, Michael, but I would love to entertain questions, anything. I know that was a lot of me just talking. So